Hello, my name is Todd Evans, and I am a Level 2 Product Support Engineer at Cole Morgan. And this video series is an introduction to the AKD Ethernet IP servo drive. Welcome to video 13 of the AKD Ethernet IP video series. In this video, we will discuss using predefined motion tasks with Ethernet IP instead of the AKD move add-on instruction. Some of the topics covered in the overview involve some limitations such as profiling, blending of moves, S-curve acceleration, and registration moves. As previously stated, these are not possible over Ethernet IP, as using the AKD move add-on instruction is limited to relative or absolute point-to-point moves, which are trapezoidal. However, the blending of moves, S-curve acceleration, and registration moves are possible using predefined motion tasks in the motion task table. The method described in the AKD Ethernet IP communications manual under running a stored motion task sequence, which is in the position mode section of the manual, can possibly accommodate some applications that need blending of moves, S-curve acceleration, and registration moves. This is also called the block method. Below to the left shows where this is located in the table of contents of the AKD Ethernet IP communications manual, and to the right it has the description of how the running a stored motion task sequence works. To demonstrate how the block method works, suppose there are existing motion tasks in Workbench, as shown below. Recall that motion task 0 should be reserved as the AKD jog and/or AKD move add-on instruction writes to motion task 0, much like a scratch pad. The focus here should be on motion task 3 or 4 in this example below. You can see that the motion tasks are already created using Workbench and stored to the motion task table. As shown in the table below, byte 1 of the command assembly is the block number. This serves as a pointer to the motion task number. Here's an example using the sample project axis called axis_1. You can see in the structure I've highlighted axis_1.output.data in brackets 1. So in the structure that the AKD drive add-on instruction updates or reads, writes, etc. to the generic Ethernet module, ultimately, this value can be changed by PLC code in order to set the block number. In the screenshot from the AKD Ethernet IP communications manual below, it shows that bit 1 of the control word, which is byte 0 of the command assembly, serves as the trigger to start block, where a rising edge transition from 0 to 1 causes the execution to start. I've highlighted the description. Start block executes a motion task sequence previously generated and stored in the drive. Put the starting block number in the block number field byte 1 and transition this bit high to 1. The load start flag must be 0 while transitioning the start block. Prerequisites prior to triggering the start block: the load start, which is called in the structure load data start profile, which is bit 0 of the control word, must be 0. The smooth stop must be 0, and the hard stop must be 0. If you look at the screenshot below, these are noted by a red box, and you can see that they are all 0. The enable must be a 1. You can also see that noted as a green box below. These must be confirmed by the response assembly status words. The drive must be in service position mode, because remember, the block method utilizes motion tasks. Likewise, the drive must be homed. The home level or bit 5 of the status word 1 of the response assembly must be 1. This may seem obvious, but whatever motion task number you're going to point to, it must exist or you'll get errors. And again, to repeat, bit 1 of the control word, byte 0 of the command assembly serves as the trigger to the start block, which is a rising edge transition from 0 to 1. I've highlighted that in green below the start block bit in the structure. In the response assembly during execution, bit 1 of status word 1, as shown below, confirms a block is in execution. And byte 1 reads back the executing block number, is highlighted at the bottom. Now I'm going to demonstrate this manually. So currently in Workbench you can see that I'm in service position mode and the drive is active or enabled, and I'm not yet homed. So I'm going to first home the drive using the AKD home add-on instruction. You can see that the home is found and done. Position feedback is 0. I've created 2 predefined motion tasks 3 and 4. Remember that motion task 0 should be reserved for the AKD move or the AKD jog add-on instruction. So when you're using predefined motion task and using the block method, you should use a motion task number 1 or higher. So in this example, I've created 2 motion tasks, and imagine that the application is a linear actuator where the 2 primary positions is extend and retract. So I've created a predefined motion task number 3 in Ethernet IP counts 655360 is 10 motor revolutions. And then I have some velocities and accelerations defined, and the type is absolute because I'm doing an absolute move. And then for the retract or return, motion task 4 is defined with the same setup except the target position is 0. And I'm going to save the device to make sure that this is saved to non-volatile memory. So now I'm ready to start the block moves. So returning to the PLC, I've expanded out in the sample project axis 1 and the control bits and also the output data. So we're homed and at the 0 position, so I want to extend. So we said the extend is motion task 3, and byte 1 of the output data of the structure is the block number. Okay, the prerequisites, you'll recall, this loads data start profile bit must be 0. Smooth stop and the hard stop must be 0 as well. I have to be enabled. If I wanted to look at the status, I could also check that the home level is a 1 and I am enabled. I'm going to collapse that. So now I'm ready. So I'm going to make a 0 to 1 transition. I'm going to go back to Workbench. You can see 3 is executing. And it's completed. If I look at, I could look at the watch window, or I can look at the position loop and see that I'm at the target position. So now moving back to the PLC, I am going to reset the start block bit to 0. I'm going to set the block number in byte 1 of the output data to 4 for the retract or return move, and now I'm going to trigger it with a 0 to 1 transition again. Going back to Workbench in the motion task table, you can see that motion task 4 is executing. It's finished, and I went back to 0. Okay, I'm going to repeat the extend and retract, but this time I'm going to focus on the status in the response assembly. So I'm at the 0 position and I want to extend, which is the block number or motion task number 3. I'm going to start it. You can see the block and execution bit and the status word turns on. You can look at the byte 1 of the response assembly, and it's a 3. Just keep in mind that even after the block and execution goes back to 0 after the move is done, byte 1 of the response assembly for block number, it stays a 3, it doesn't go back to 0. Now I want to set the trigger back to 0 for the start block. I want to change the block number in the output to 4. Gonna trigger it. Block and execution is a 1. Go down to byte 1 of the response assembly. It's changed to 4. When the move is done, the block and execution goes back to 0. 2 new add-on instructions were included in the version 5.0 add-on instruction library that used the block method. The AKD set motion task add-on instruction allows a motion task to be created or changed from the PLC. The AKD start motion task allows a motion task specified by the motion task number to be started from the PLC. These add-on instructions allow the programmer to take advantage of predefined motion tasks in the block method without having to create a lot of additional code to perform the steps previously demonstrated manually or by forcing. In the screenshot below, I show an implementation of 2 rungs with the AKD set motion task and the AKD start motion task add-on instructions. Now I'm going to demonstrate the usage of these. In my project, I've added 2 rungs for the triggering and execution of the 2 add-on instructions. Before we demonstrate the AKD set motion task, let's focus on the AKD start motion task add-on instruction. I've given it an instance name, point to the axis that is correlated to this add-on instruction, and I have a variable. You could hard code it, but I created a variable for the empty num that I want to point to. And effectively, this is the block number, and that's what the add-on instruction does internally, is it uses the block method, and so this is going to wind up being the block number. If you recall previously in the demonstration, I already had 2 predefined motion tasks that I created using Workbench. This is one method for using the block method, is that you use Workbench to create the motion task already and save it, and they're hard coded in there, and in that way unless you need to change them, you don't even use the AKD set motion task add-on instruction. You're only going to use the AKD start motion task add-on instruction just to point to the motion task number and to start it. So in the previous example, when I did it manually, we had an extend and a retract. Motion task 3 was the extend, so I'm going to set that as my motion task number, and then I'm going to toggle to trigger it. The in process bit turns on, indicating motion. And then when the move is finished, then I get a process complete output bit to turn on the AKD start motion task add-on instruction. If I jump back to Workbench, I can go to the position loop and confirm that I did go out to the target position of motion task 3. Now if I want to retract, that was motion task 4, and I'm going to re-trigger this. Actually, while it's in progress, I can go to the motion task and see that motion task 4 is executing and running. Now it's finished. So that's one way to utilize the add-on instructions for this method. So let's suppose for a moment that you don't want it to be hard-coded, or you have a default that's hard-coded, but you need to change periodically the extend position, for example. So let's say you have a recipe in a batch where in the first batch the target position was 50,000 counts. But let's say that the next time around the HMI or recipe or some other method for changing this needs to be 100,000. So now I've left everything alone. I want to change motion task 3 to the new go-to position or extend position.
I'm going to make one final minor change here. I'm going to set the MTCNTL control word for this set motion task to 0, so that we're going to continue with the example application of extend and retract, or go out and return motion task working in absolute mode. And I'm going to go ahead and trigger it. Back to Workbench, go to motion task. You can see that the motion task target position changed. Everything else stayed the same. Now I'm ready to go back to the PLC, and now that I've altered the extend go-to position, I'm going to use the AKD start motion task add-on instruction. You could potentially, in your application, actually have 2 instances of this run, and one for the motion task 3 extend and motion task 4 retract. But just for this example, we're just going to work from one add-on instruction alone. So I'm going to go ahead and I'm going to toggle it. Process complete. So if I go back to Workbench, I can see here from the watch window that I did go out to the 100,000 count target position. Now I'm going to go back to the PLC. I'm going to change this to go to the return. And process complete. If I go back, now I'm back at the 0 position.